The International Space Station is used as a research laboratory on orbit and also as a means to encourage students in their studies of science, technology, engineering, and math. Recently, the Center for the Advancement of Science in Space, the nonprofit that manages the ISS National Laboratory, partnered with a number of companies to develop a competition for students from the 7th to 12th grades to design an experiment to fly on the station. The results of that competition, called Genes in Space, is on Space Station right now. Recently, my colleague Gary Jordan spoke with the program manager, Scott Copeland of Boeing, here in Houston, and started by asking where the idea for this experiment came from.
Well, Boeing is celebrating their 100-year anniversary of being in business, so we certainly want to encourage young men and women to continue their education with science, technology, engineering, and math. While we were participating in the Mass Challenge with cases last year, I ran across a company that had a little DNA replicator called the miniPCR. So I found it interesting because the particular device is small, it's very compact, and uses very little resources. So I thought it'd be a perfect application to put this on board the space station. So as part of the discussions, we ended up buying 2 of those units for evaluation purposes. And then we had some follow-up discussions with the founders of their company. And the company itself is very focused on STEM education, trying to put biotechnology devices and hardware into the school systems so that young women and men, high school and junior high have access to this. Most schools, even anywhere in the U.S., don't have access to that type of technology.
So because of that, tell me about some of the response from the students and how that competition was judged.
Well, the response from both the students and the teachers has actually just been outstanding. We've conducted workshops across the country where we did simulations. For example, the last one we did was at the Hudson Alpha Institute of Technology in Huntsville, Alabama. We brought students and teachers into the classroom for a 6 to 8 hour session. We did a simulation for a contamination experiment. We'd pre-staged food containers on the International Space Station for the ultimate journey to Mars. And we had a call up from the ground that warned us that one of the containers might have been contaminated. And so we did the simulation, let the students take DNA samples and determine which container had been contaminated. So it really got them engaged with hands-on workshop environments such as that.
Excellent. And your winner was a 17-year-old from Bedford, New York. So what are the goals of the research that she proposed?
Well, we really had 2 goals on this. First, we wanted to see if a what's called PCR, polymerase chain reaction, could be done in space. So first thing we wanted to do was check out the experiment itself, make sure the device would work in 0 gravity. And her experiment was focused on, we know that the immune system from astronauts is compromised. It's suppressed but we don't really know what's causing all of that at this point. So she is looking at changes in the genetic makeup, the changes to DNA, and see if she can determine a link between that and the immune system suppression.
So how will Genes in Space be executed then in space?
Well, we've completed 3 sample runs to date, so we're through and we're just waiting to bring our samples back. We extracted the DNA from zebrafish using the laboratories at Yale University. The samples were pre-processed with the reagents and then packaged and frozen. Those were then shipped to the Cape where they were launched to the station. 2 weeks ago, the first samples were taken out. The mini-PCR was set up in the node on the workbench area. We checked it out. The temperature profiles looked very good. Then we loaded the first sample, which was Anna-Sophia's sample. It was processed and then returned back to cold storage. And then we had 2 reference samples that were also processed. So hopefully everything went well, and we're looking forward to getting the samples back. They'll be returned at the end of the month, and we'll see what the results were.
So the results are coming. How do you think the results of her experiment might be applied to support future space missions?
Well, I think this will open the door for us. If we can look to see which genes have been turned on or off through this particular process called methylation, if we can determine which ones have been turned on off, that will open up the door for discoveries of, or at least looking into any other type of diseases to see how the effect of microgravity might affect it.
Well, it seems like it's a very popular experiment that's going on station. Do you think you'll have a lot of contestants for next year's competition?
We're very excited about next year's competition. So April 25th marked National DNA Day, and as part of that, we had the end of submissions for the Genes in Space 2 competition. So we've already received over 400 applicants. It really reached across the U.S. We had 90 schools participated and over 900 students. So we're quite excited. There'll be a lot of late nights between now and mid the month to determine down to 5 finalists. And those 5 finalists then will be tutored by Harvard and MIT PhD, either students or PhDs themselves, scientists and researchers, for about a 6-week period. At the end of that conclusion, then we will down select. They'll come to San Diego and for a down select to a single winner, and they'll do oral presentations. And we have a very distinguished panel of judges that will participate in that. And the winner will be announced. And once that occurs, then New England Biolabs, who's one of our partners, along with miniPCR, Math for America, and CASES, they're going to host them for a 1-week session in New England. So they'll be able to live on their campus and work with their scientists and researchers to perfect their experiment for our next launch.
A lot on the schedule for these for the next couple months, but in the meantime, we'll be looking forward to the experiment for the results from the Genes in Space on the International Space Station right now. Scott Copeland, project manager of Boeing Genes in Space, thanks for being with us today.
Thank you very much for having us here.